Okay, so there are five types of symmetry operations that include identity, reflection, inversion, proper rotation, and improper rotation. To find the point group, we need to understand these symmetry operations. So number one is identity. Whenever you're looking for identity, remember that the symbol is E, and identity refers to that the rotation will be 360 degrees. So if I'm looking at the molecule, there will be no change, right? So we're going to be rotating the molecule 360 degrees without changing anything. Second type of symmetry element is proper rotation. Proper rotation, this is given a symbol Cn, where n can be your any number symbol. How do you find n? N is equal to 360 over n. Any So to find n, we're going to divide the angle with the 360. So how number of time molecule is rotated, we're going to divide it by 360 to find the n. For example, if you divide 360 over 180, you will get 2. 180 plus 180 is 360. So your n is number 2 if the molecule is rotated 180 degree. So proper rotation is Cn. Again, if the molecule is rotated 120 degree, you're going to divide 360 by 120, which will give you 3. So the rotation will be C3 rotation and the axis will be C3 axis, and we can continue. Whatever the angle is, you divide it by whatever the rotation angle is, you divide it by 360 to get your number n. This is your principal axis or principal rotation. Okay, another thing to remember is that whenever there is two or more principal rotation in one molecule, for example benzene have C2 rotation along the axis and there is C6 rotation. So what you're going to do is you're going to take the principal axis as the highest order of the proper axis. So if C6 axis is present, like here in the benzene molecule, in the center of the molecule there is C6 rotation. C6 mean that molecule can be rotated 360 degree all around, right? And then C2 rotation means C2 is here 180 degree, so every angle is 180 degree, and then C6 is the highest order. So you're going to consider the principal rotation axis to be C6, which is highest order. Next we come to mirror plane. Okay, here this is the mirror plane. Mirror plane is given the symbol sigma. Sigma h is for horizontal plane, and then sigma v is for vertical. Sorry, my spelling of vertical, it's v. Vertical axis and horizontal axis. Mirror plane, so they can be classified according to their relationship to the principal rotation axis. Now, what is the relationship for the horizontal mirror plane to the principal rotation axis? Horizontal reflection plane are perpendicular to Cn. Cn is your principal rotation axis. And then mirror plane, vertical mirror plane reflection or vertical reflection plane contain the principal rotation axis itself. Then vertical mirror plane is also extended into dihedral reflection plane. Dihedral reflection plane is given the symbol sigma d. Dihedral reflection planes are the vertical reflection plane that bisects 2C2 rotation axis. Okay, to understand the mirror plane even more, let's look at the platinum chloride molecule. So platinum, it will go in the middle, Pt, and then Cl4, chlorine and chloride, right? So this is your platinum chloride, right? So first let's consider the horizontal reflection plane. I'm going to mark the horizontal reflection plane in red here. Okay, so this is your in circle horizontal reflection plane. To find the principal axis, let's find the principal axis. So the chlorine is at the 90 degrees angle, right? So there is, if you look at from the middle point here, there is C4 rotation. How C4 rotation? 360 divided by 90 will give you C4. So chlorines are at the 90-degree angle. Then another type of rotation can occur in the mirror plane. It is this along this angle and along this axis. So this will be your in blue, or let me just put it in the other color. This is your another type of rotation that can occur is like this. This will be your principal axis, which is at the 120 degree. So we will say that another principal axis is C2. So there is one C4 and there is another one C2. Now to give a principal axis, we going to look at the highest order of the proper axis. So C4 is the highest order. We will say that this platinum chloride have the C4 principal rotation axis. Then we talk about the dihedral plane. If I draw a line from here in the platinum chloride, right, and then this is, you can say, is your vertical line. You can see the vertical angle. On the top is your horizontal angle, right? And then we say that dihedral plane will bisect 2C2 rotational angle. So this line is bisecting 2C2 rotational axis. C2 is your 180 degree angle. So the platinum chloride contain the horizontal reflection plane, which is marked in the red, vertical reflection plane in the purple, and then dihedral reflection plane, which I have marked in the by the single line bisecting the 2C2 rotational axis. Next we have inversion. What is inversion? Inversion operations takes any point through the inversion center which are at the equal distance or equidistance point on the opposite side of the inversion center. So let's look at this diagram here. If we take three planes x, y, z, the inversion center for x is minus x, y minus y, and z minus z. So this is the equal distance. So if we look at the x-axis, there is circle, there is triangle, and this is your y-axis, and this is your x-axis, right? So this is your y-axis, this is your x-axis, right? So if we have to see the inversion, this triangle will go on top, this circle will come here. So this is your inversion along the y-axis. If we take this side and there is blank here, we'll say that the inversion will be along the x-axis, this inversion will be along the y-axis. X will turn into minus x, y will turn into minus y. Then z angle, we draw one line from here, z will turn into minus z. Now let's look at in forms of number. So I have drawn one molecule here just to give you an example, right? Okay, so 1 2 3 4 5 6, I've given those numbers to y-axis, x-axis, and z-axis, right? Let's look at y-axis first. If you have to inverse the y-axis, 6 will go on top, 1 will go at the bottom. So this is inversion along the y-axis. Again, x-axis, 2 will come on this side, 4 will go on that side. So this is the inversion. Equidistant point is in the center along the x-axis. Equidistance point, inversion is marked as I. Then along the z-axis, 5 will go this side, 3 will go that side. So here is your new figure. This is the inversion taken place in this molecule. Then last element of symmetry is your improper rotation or improper rotation axis, which is given the symbol Sn. This is quite difficult to visualize. It is a combination of rotation with respect to an axis of rotation or principal axis, followed by a reflection through a perpendicular plane to that of the Cn or proper rotation. So I have given you the equation. Sn, improper rotation axis, is the mirror plane, horizontal plane. Okay, so we were looking at the improper rotation axis. Sn equals Cn times reflection along the mirror plane, which is horizontal plane, which is perpendicular to the proper rotation, right? In short, we can say that improper rotation or improper rotation axis is the operation which is equivalent to the proper rotation, which is given symbol Cn, followed by the reflection along the mirror plane, horizontal mirror plane, which is your sigma h. Okay, so let's look at the example. We can say methane molecule. So this is methane molecule, you can say. Okay, so there will be reflection along the perpendicular plane and reflection along the horizontal plane. This is your S4. Let's make circles here for us to easily understand. So in methane, the S4 improper rotation axis will rotate 90 degree and rotate the plane in H out of the plane and vice versa. The perpendicular reflection then exchange the in and out of the H plane, returning them to the original conformation. In this example, neither the C4 rotation or the perpendicular reflection are symmetry operation on their own. So we will say this is a improper rotation or improper rotation axis, which is Sn. Sometimes the new symmetry operation form by carrying out two or more simpler operations successively to result in an indistinguishable configuration. Like example, the improper rotation axis above results from the rotation about an axis of rotation Cn, followed by the reflection about the plane of plane perpendicular to the axis, which is given the sigma h symbol, horizontal reflection, right? Note. And then in above example, we said that the in this case not Cn Cn in this case need not to be a symmetry element for the molecule. For example, staggered ethane has an S6 symmetry element, although it does not have a C6. Another example of a symmetry element that result from a combination of two different elements is your inversion. Inversion center, which result from a C2 rotation followed by a reflection about a plane perpendicular to that of the axis, which is your horizontal plane. We also say that inversion center, this is a special case of an improper rotation axis. Why? Because it results when the first equation in the first equation n is equal to 2. So we say inversion is equal to S n is equal to 2, so S2. Then another example, any symmetry operation can be carried out multiple times in a row. If we take BH3 molecule, if it is rotated twice by 120 degrees, the two-step operation can be symboled as C23. When the C3 operation is performed a third time, the molecule will return to its original configuration. So it will be C3 3. This molecule will return to the original conformation. So we can say C N N equals E. So any symmetry operation can be carried out multiple of time. This symbol will represent that. Now we know all the symmetry elements: identity, which is given symbol E; proper axis, which is the rotation by 360 over n, and it is given symbol Cn. Then we looked at symmetry plane, which is reflection in the plane. It is represented with the symbol sigma. Inversion center, equidistance point from the equidistance point, for example xyz will invert into the minus x minus y minus c, and it is given the symbol I. And then improper axis, rotation by 360 over n, followed by the reflection in the plane perpendicular to the rotation axis. This is your improper rotation, which is given the symbol Sn. So these are your symmetry elements which will help us find the point group.